Hey guys, today we are looking at 6.5's notes, which is all about solving exponential equations. We've got our regular 4-box notes, so we're going to go ahead and jump in here with box number 1 with some definitions on what an exponential equation is and the way that we'll go about solving it. So to start off with, an exponential equation, as you would expect, it is an equation, of course, but specifically it's an equation with variable expressions. So we've got our variables as exponents. So either on one or both sides of my equation, I'm going to have an exponent in both of those or one of those sides, and that's where my variable happens. So my x or my y, whatever I'm solving for, happens in my exponent. And we've got a couple of different ways that we'll look at this. One major way of solving it is something that's called the property of equality. Now we're going to define this 3 different ways. I'm going to give you kind of the definition using words. We'll look at it algebraically, what that means, and then with an example with some actual numbers put in there for the property of equality. So what the property of equality says is if 2 expressions with the same base, combine those words together, with the same base b are equal, then their exponents must also be equal. So we have 2 things that are set equal to each other that have the same base. In order for that equation to be true, their exponents must be equal to each other. So a little example here of what that would look like algebraically, what that definition says. If we have our b, our base that's bigger than 0 and isn't just 1, so we have to have positive base and not 1, same requirements as regular exponential. If we have that to be true, then we know that b to the x power equaling b to the y power is true if and only if, so that's what that means. It's a little fun math term, if and only if x equals y. So that double F if, Mr. George uses that and use that in kind of proof-based stuff. It's a way of abbreviating the phrase if and only if, because that is something that we'll use in more advanced math classes and stuff. It just means that this is true if this is true, and it's only true if that second thing is true. So in this case, b to the x power equaling b to the y power is true when x equals y, but it's only true when x equals y. So what that could look like with some actual values put in there, we could say that if 2 to the x power equals 2 to the 5th power, the only way that that's true is if x equals 5. And that's really the crux of what we're doing here. We're trying to solve these equations where if the bases are the same, or if we can rewrite our equations with the same base, then we can just focus on the exponents being equal to each other to be able to solve for whatever my variable is. So that's what we're going to go ahead and do in box 1. We're going to start for box 2. We're going to start with problems that have the same base. So if we know 2 things have the same base, they're set equal to each other, then their exponents have to be equal to each other. So if 3 to the x plus 1 equals 3 to the 5th, that tells me that x plus 1 has to equal 5. So then we can just solve that little equation like we did back in chapter 1, and we get that x equals 4. Now I'll show you on this first one. You can choose whether to do this or not, but how we would check our answer, just like we've done in the past, we would take my solution for x and plug that back into the original problem. So I'm going to go ahead and just test that with this first one. So I'm plugging 4 in there for x, 3 to the 5th. So here we end up with 3 to the 4 plus 1, which is 5, equals 3 to the 5th. You can evaluate that if you want to, but we can see that both sides are definitely equal to each other. So we can leave it like that. Or if you want to evaluate, 3 to the 5th power is 243. So 243 equals 243. If you want to go further, we know that that is definitely true. So that's how you would check your answers. Which for something simple like this, probably not as important. As we go to some of the more complex ones, probably a good idea to check our answers. But I just wanted to show you on this first one how to do that, and then from here it's your choice on whether you go back and check your answers. All right, number 2. Number 2 has 6 equals 6 to the 2x minus 3 power. Now we definitely have base 6 on both sides, so that's good. But what's a little bit confusing on this one is I don't see an exponent on my left 6, so I'm going to have to make sure I write one in there. We should know that if you don't see an exponent, there's a little imaginary 1 there, because 6 to the first power is 6. So now I have exponent on both sides. I can just set those exponents equal to each other. So then 1 equals 2x minus 3, and I can solve that equation like I would normally. Inverse operations, I have to add 3 to get my x term by itself. So 4 equals 2x. Divide by 2 to get my x all the way by itself, and we get positive 2 for my solution. Last but not least in this box, 10 to the 3x power equals 10 to the 2x plus 3 power. So again, I have exponent equal to exponent because my base is the same. Even though I have variables on both sides, it does not change my process at all to get my equation set up. I'm still just focusing on the exponents being equal to each other after I have my base the same. So then from here, it's just a little bit different. Still a chapter 1 problem. I have to get my x's together on one side first. So you can either move your 3x to the right with your 2x plus 3, or in this case, I'm going to get my x's together on the left side because then my number will be on the right. And actually in this case, that is all we need to do because 3x minus 2x is just x. So we have x equals 3. Okay, moving on to box 3. Now this is where we have to do a little bit of critical thinking because we're trying to solve problems that do not have the same base. Because we need to make sure that our bases are the same before we can use that property of equality. That was the requirement. My base couldn't be a negative number, and it can't be positive 1. But I have to have my base the same in order to get those exponents equal to each other. So when we have two numbers that are equal to each other that are not the same base, you have to try and figure out a way that you can rewrite one or both of the two sides so that they are the same base. Now in this one, for number 4, we've got 5 to the x power equals 125. Now that 5, that's a prime number. I can't rewrite the 5 as anything else. So I know that that left side I'm going to have to leave as it is. 5 to the x power has to stay that way. So now I'm just trying to figure out 5 to what power could be 125. So you can either use your calculator for this and just kind of play around with it, test some different exponents on 5, or maybe you're just big brain and you just know this off the top of your head, that 5 cubed, 5 to the 3rd power, is 125, and then you're good to go. 5 to the 3rd power is 125, so now that I have those bases that are the same, I can just focus in on their exponents. In this case, there's nothing else to solve because x was already by itself on that left side, so x equals 3. For number 5, I've got 4 to the x power equals 2 to the x minus 3. So here in this one, my 2 is going to have to be the same. There's no other simpler way to rewrite 2 other than just 2. So what I'm going to have to do is rewrite this 4 as a base of 2. 2 to some exponent power gives me 4, which in this case, 2 squared gives me 4 equals 2 to the x minus 3. Now, before I can combine those together, like to set the exponents equal to each other, I have to have just my base of 2 to a single exponent. So here I have to do power rule on the left side. 2 squared to the x power to a power tells us we multiply. So this is 2 to the 2x equals 2 to the x minus 3. And now that we have that, we can set my two exponents equal to each other. 2x equals x minus 3. And I can get my variables together on the left side. Subtract x to move my x's over. I end up with x equals negative 3. And that's my solution for number 5. Number 6 is extra tricky because if you're looking at this, 9 is the smaller one. So I usually try and focus in on that one first. See if there's a way to rewrite my other base as that base. So in this case, if I'm trying to figure out if I can do 9 to some power to get me 27, but I can't with this one, I have to rewrite both sides as a different base. So in this case, what I'm going to have to do is say that 3 squared is 9, x plus 2, equals 3 cubed to the x power, and rewrite both sides as base 3. Now, doing power rule here, I have to distribute my 2. It gives me 3 to the 2x plus 4 equals 3 to the 3x power. And now I've got 2x plus 4 equals 3x. I can move my x's together on the left side or the right side, and I get 4 equals x. All right. Last and not least, box 4 is dealing with how we solve an equation when our bases are between 0 and 1. So that means we're going to be dealing with fractions, which means we're dealing with negative exponents. It's going to be our way of handling those. So looking at number 7 here, we've got 1/2 to the x power equals 4. So I'm going to have to rewrite both of those as a different base in order to get them to be able to be set equal to each other for their exponents. So what I should notice is that my my denominator in 1/2 is a 2, and I know that 4 is 2 squared. So I'm going to rewrite both sides of this equation as a base of 2. So 1/2, like we just said, we know that's 2 to the negative first, and that's still to the x power, and we know 2 squared is positive 4. I have to apply power rule there on the left side. Negative 1 times x gives me 2 to the negative x power equals 2 squared. So then since I have the same base of 2, now negative x equals positive 2. And then depending on your philosophical beliefs, either multiply or divide by a negative 1 on both sides there to get x by itself instead of negative x. We get negative 2 for my solution. And final problem here, number 8 has 4 to the x plus 1 power equals 1/64. So what I would check first to see if there's a way to rewrite 64 as 4 to some exponent, instead of having to rewrite both of these as base 2. I think I can figure out a way to rewrite that. Here, just a little side note, 4 cubed is 64. So I'm going to be able to use that to my advantage. I can rewrite this that right side as 4 to the negative third, because again, that negative is going to flip it over up top. So I can rewrite this as 4 to the x plus 1 equals 4 to the negative third power. And now I have those bases the same. X plus 1 gives me negative 3. So if I subtract 1 on both sides, x equals negative 4. And that's all I got for you. That is it for 6.5. Your homework for tonight is page 329, 4 through 20, just the evens. As always, if you have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys reach out and let me know. Otherwise, have a fantastic day. We'll see you guys soon.